Hey guys, I hope you're doing good. In the last video, I had shown you how you can set up a pipe flow simulation in SolidWorks. We set up a simple problem, we got some data out of it, and we really did not investigate it further. So in this video, I'm going to be working towards that. We'll set up a pipe flow simulation, create a line probe, get the velocity and shear stress information, and also run a parametric study. So to get started, let's create a new part file, and the approach that I'm going to be taking towards the geometry is exactly the same. We are going to create a circle first, and then we are going to extrude it. So this time I'm extruding it to 1 meter. So the pipe is fairly long. Once the extrusion is complete, I'm going to select the top face and the bottom face. Looks like only one face got selected. So let me select the two faces, and then I'm going to create a shell. Let's click on preview. That looks good. So we've created our pipe. And in addition to this, we'll also be creating our line probes. So now the assumption is, the flow is going to take place, or the flow is going to enter the domain from this side, from the right hand side, where my origin point is, and it's going to exit out through this side. So we are going to place a couple of line probes near the exit or the outflow of the domain, and we are going to see how the flow quantities change. To do this, I'm going to put the geometry in the top view and create a new sketch. I'm going to create a line, something like this, and let's add some dimensions. Okay, so roughly at 0.05 meters from the outflow boundary, I'm going to be measuring my velocity profile. And let's exit sketch, and what I'm going to do is I'm going to create one more sketch, and this time the line is going to be behind the first line that we created. Enable smart dimensions, and let us say the distance is 0.1. Okay, so our objective is to plot the velocity, pressure and shear stress across these lines to see how they change. And you can actually learn a lot about the simulation by creating these type of line probes. And in a later video, I'll show you a different problem, which is called as the backward step flow problem, where I'll also show you experimental data that has been measured across these lines. We'll take a look at the relevant paper and the results that were obtained. Alright, so now that I have my line probes, I'm all set. So let me save my simulation. I'm going to call this as pipe flow with line probe. So once I've done that, let's click on flow simulation, and we are going to create some lids. Like I said before, lids help us create that closed watertight volume, which is required for CFD simulations. SolidWorks uses lids. In other softwares, it might be called as patches. Okay, so I've created two lids, and I think I'm all set. So let's go to flow simulation, click on new, and the project name, I'm just going to call it pipe flow with line probe. Alright, so that's going to be my project. And then let's first get started with the input data. So right click on input data and click on general settings. We are still going to be running a steady state simulation, so this doesn't change. Fluids, so this time we can simulate water flow. We are not interested in cavitation. The flow type is still laminar and turbulent, and initial conditions we are not going to change. Alright, so let's click on boundary conditions and insert some boundary conditions. So this is going to be my outlet face. So let me right click, select other, make sure that you select the right face. If you didn't see that, let me do that again. Right click, select other. Let me make this guy a bit big. You can see that I have to select this guy and I should not select this guy. Okay, make sure that you select the one that says face at lid 1, okay, instead of just selecting the lid. Alright, so I've selected that, and let's say that this is a pressure outlet and I'm specifying the static pressure in this particular boundary. Alright, so on this side, let's create a new boundary condition. Make sure that you select the right face and velocity inlet, and I'm going to say that the velocity is 10 meters per second. Alright, so I think that sounds reasonable. So the next thing that we want to do is for global mesh, let's take a look at the basic mesh here. That seems like a good starting point, although we just have 4 mesh points across the diameters, which is not good. So what we're going to do is we're going to right click and then so what we're going to do is we're going to right click on global mesh and click on edit definition, and instead of specifying the mesh automatically, I'm going to use the manual option. So we can see that Z axis is basically along the pipe and X and Y axis are describing the cross section, right? So along X and Y, we definitely need more points. So I'm going to say 10 points along X and Y. Okay, so I think this would be a reasonable first guess. And along Z, I don't need 114 points, so let me maybe start with 50 points. So you can see that the mesh is stretched along the Z direction. This is perfectly fine. A lot of people do this. And I think we should all be good. So now let's go to results, and then we are going to set up a new XY plot. So this time, we are going to first make a plot along sketch number 3 first. And we are going to be looking at, say, the velocity, okay, velocity magnitude, and then let's just call this plot velocity, and then similarly we can create new plot for the shear stress. Okay, and then I'm going to select the same line and let me just call it shear stress. Okay, it's also possible to compare the velocity or pressure information between these two lines. So what I can do is, let me create another velocity plot, but this time for selection, I'm selecting both of these lines. With respect to the mesh, I'm going to hide the basic mesh, and we still need to add one more boundary condition, which is the wall boundary. Right click, select other, and let's just make it into a real wall. That's it. So we should all be good now. And let's run the simulation. Okay, I don't have a whole lot of cells, so that's good. So the simulation is complete, so let's take a look at some plots. There you go. So that's my velocity plot. For some reason the shear stress plot doesn't show up. Okay, so I think I have to figure out why that's happening. Let's take a look at the velocity comparison. There you go. So you can see that on both lines the velocity is pretty much the same, which is a nice thing. I'm just going to look for one more plot here. So let me create a new cut plot, and the way I'm going to do this is, I'm going to make a cut plot near the outflow, and I'm just going to see how the velocity looks in that cross section. So the cut plot is already made, so I'm going to make my solid geometry transparent, and this will help me take a look at the cut plot. And I'm just going to edit this guy so that I also see the mesh. So you can see that the profile is not regular, it looks very strange, and this is because the grid that we are using is fairly coarse. So we can perform a parametric study to see how the number of grid points along X, Y, and Z direction affect our results. So let's hide our plots, and then I'm going to run a new parametric study. So let me first add our simulation parameter. In this case, I'm just going to add the number of cells along X, Y, and Z, and that's basically all I want to do. Alright, so I have my number of grid points here, and then for output, let's add some results. So we are going to include our cut plot, which is the velocity plot, and all of our XY plots. Alright, so I'm just going to call this analysis grid dependency test. And for scenario, we are going to start with 10, 10, and 50. That's our baseline case. I'm going to copy this design point, paste it, and this time I'm going to increase the number of grid points by a factor of 2. Okay, so let's create one more, and we just repeat the process. So this time it's a factor of 4 when compared to the baseline. Okay, so these are the 3 different design points that I want to run. So when I'm ready, I can just click on this run button. And we just have to wait for the simulations to complete. Alright, so the final design point took a lot of time to finish, but the runs are complete. So let's take a look at the first design point. The results are fairly choppy because the grid is coarse. And as we move on to the second design point, you can see that the choppiness is getting down. And if I move on to the final design point, it looks even better. Alright, so let's take a look at the velocity plot. Alright, so here you can see that the velocity is matching pretty well, and as the grid is getting refined, the velocity is converging to an answer. This is what you call as a grid dependent solution. Now for shear stress, for some reason I'm unable to generate the plots. I don't know why. We have to take a look at it. So the other type of plot that we can do is, you can compare the velocity profile at the different lines in a given design point across the other 2 design points, but this might be a bit confusing. So what you can always do is, for example, all I did is I just clicked on the Excel export button, and it gives us all the velocity plots, and it gives us all the information in a table form. So if you have experimental data for this particular case, you can include that in a table as well, and then compare your results. Alright, so I hope this video was useful. What you can also do is run a parametric study where you change the inflow velocity condition or even some of the turbulence parameters to see how the velocity profile is getting affected. Okay, I'll see you guys in the next video. Bye.